Thank you so much for the opportunity to talk about my study, and I feel after Intel introduced the life course concept, it makes my topic much easier to start. So basically, we would like to see how the grandparental socioeconomic status and the parental BMI influence the children's BMI growth patterns. I think we all recognize the obesity epidemic in recent decades, and the number is especially alarming for childhood and adolescence. And obesity prevalence is disproportionately uh, distributed. As it is shown in this figure, there's huge gap between the children from most deprived and the least deprived areas, and the gap became even wider in recent years. So we would like to know what are the risk factors for obesity at a different life stage. And the parental BMI is a strong risk factor because the parents pass down the genetic information to the children. They also provide the family rearing environment. And there has been consistent evidence suggesting the intergenerational association of obesity in the family. But previous studies might only focus on certain time point, like a screenshot. So we couldn't get a complex picture of the BMI, the whole BMI growth trajectories. On top of that, family socioeconomic position is another important factor because it influences whether we have access to healthy behaviors and knowledge resources, etc. Here we use previous studies also established the inverse association between socioeconomic position and BMI and obesity and the risk of obesity, but mostly using individual socioeconomic position or the parental SEP. Here we use the grandparental SEP basically for three reasons. We think the origins of obesity lie in the early stage of life. So the parental nutrition status was actually influenced by their parental socioeconomic position. Secondly, there might be cumulative risk of risk exposure since the childhood contribute to the association between early life poverty and elevated elastic load and stress and further increase the obesity risk. Lastly, the grandparent might influence the grandchildren directly by passing down the knowledge or providing financial support. So based on that, we would like to test the hypothesis that children born with parents who are overweight obesity have a higher risk of obesity and have early onset of obesity. Secondly, whether this parental association obesity would be influenced by the family socioeconomic position that is measured by the grandparental socioeconomic position. Based on the reinforcement theory, this lower family socioeconomic background might strengthen this intergenerational association. To answer that, we used the data from a longitudinal study of parents and children, the aspect cohort. For those who are not familiar with the study, it's a birth cohort established in the early 90s, and more than 14,000 pregnant women were recruited. Huge effort put to collect information on demographic and lifestyle questionnaires, and the children were also followed many years. So the mothers reported their own demographic and lifestyle factors. They also reported their children's anthropometric information and their parent education. Their partners were also recruited in the study, so they reported their own education and their parents' education information. By linking the data, we formed this unique three-generation cohort. In terms of the offspring's BMI, we have different resources. As I mentioned before, the mothers reported the anthropometric information by questionnaires. And there are also health visits at different time points, and there are also health records. So after all, we have more than 100,000 records for more than 13,000 individuals. For each, and the median measurement of BMI is 12, which give us the power to look at the BMI trajectories. So this repeated measurement of offspring BMI from age 1 to 18 years old is our main outcome. Our main exposure of interest is the parental weight status, and we have information on both the mothers and the fathers. We determined the variable to overweight obesity versus normal weight. And further, we use grandparental SEP as a modifier in these models. To build the BMI trajectories, we used multi-level models under the missing at random assumption. This model is flexible and allows for the change in scale and the variance of BMI over time, therefore to provide the pattern of BMI growth. And we built 3 models corresponding to 3 research questions, and I will go details. First, to look at how the parental BMI or weight status influence the offspring's BMI growth trajectories. And I will just jump to the results. So as you can see in this figure, this is the BMI growth patterns by the maternal weight status, with the purple line indicate those with mothers from overweight obesity group, and the orange color indicating those from normal weight group. We could see that those with overweight obesity group have higher BMI across the whole stage, and there's deeper increase of BMI. In order to see how different these 2 groups are, we also calculated the predicted mean difference of children's BMI between these 2 groups. So these dots corresponding to the gaps between these 2 lines. So from the right figure, we can see that the difference actually started from as early as 1 year old, and it became wider and persistent around 13 years old. So this is the model from the mother side, and we did the same model using father's BMI. Basically, we observed the similar trend, except the magnitude is much lower compared to the maternal side. Secondly, we look at how grandparental socioeconomic position influence the offspring's BMI trajectories. That is to use the grandparental socioeconomic position as the main exposure. We used education as the indicator of the socioeconomic position. So those who have A-level or university degree were categorized as higher SEP, otherwise as low SEP. But we also used the index of inequality score, that is to see a person's socioeconomic position ranking in the whole population. What we did is to assign education a hierarchical value from 0 to 1, and then re-ranking it in the population. So for the upper 10% categorized at high SEP, and the lower 10% as low SEP. We did this also for the following social mobility model, because for the same education qualification, it might corresponding to different meaning in the 2 generations. So this is the result. Again, we could observe there's difference between the 2 groups. The blue line are those from lower socioeconomic background, and it is higher than those from higher socioeconomic background. So the bottom, the upper figure is the information from maternal side grandparents, and the bottom are those from paternal side grandparents. Basically, the trend are very similar between maternal side and paternal side, and the magnitude is lower compared to the parental BMI model. which suggests the BMI trajectories might be mainly driven by the parental BMI, but still here we observe evidence between association of a grandparental SEP and the BMI trajectories. Lastly, we would like to look at whether this parent-offspring BMI association differ according to the grandparental SEP and the social mobility. So there are 4 groups we are included in the model. The upper 2 lines are those born with mothers who are overweight or obesity, but from higher or lower socioeconomic position. And the bottom 2 lines are those with normal weight mothers from higher and lower socioeconomic position. What we try to compare is the difference between overweight obesity group versus normal weight group from higher SEP, and the difference between overweight and normal weight from lower SEP. So that corresponding to the yellow dots and the purple dots across the different life groups. Basically, we can see that the dots aligned with each other, and there's no big difference between these 2 groups. For example, at age 15 years old, the difference between overweight and normal weight group is 12.5 for the higher SEP group, and 12.2 in the lower SEP group. So basically suggesting there's no enough evidence of modification effect. And again, this is the information from the mother's weight status and the mother side grandparental SEP. We did the same model for the father using father's BMI and the father side grandparental SEP. Basically, again, the models are very similar with a relatively lower magnitude. These are the results when we use index for inequality score. Again, the confidence interval overlapped with each other, so it's very consistent with previous results. Lastly, we look at the social mobility, that is to look at the SEP transition between the parents and the grandparents, and we categorized 4 groups from these 2 SEP groups: those who stay stable high, stable low, and some people manage to move upward, or some people unfortunately move downward. Then we look at how this social mobility would influence this parental-offspring association. If we look at this figure, basically we observed the pattern that those BMI was highest among those from stable low group, followed by those moving downward, followed by moving upward, and the stable high group always had the lowest BMI. But again, when we compared the different groups, the confidence interval overlapped, and there's not enough evidence suggesting their difference. We conducted a bunch of sensitivity analysis. For example, I mentioned we used the index of inequality score as SEP indicators, and we also tried to treat parental BMI as continuous variable, or group the grandparental SEP as 3 categories. And in terms of there are also some missing data for the grandparental SEP, so we used multiple imputation to handle this missing data. But all the results are just consistent and wouldn't substantially change the results. There are some limitations with the study. Like I mentioned, the anthropometric information of both the parents and the children were reported by the parents, so there might be measurement error. But we think in terms of the children's anthropometric information, it might be not differential, therefore just bias the results towards the no. And across the study, we used education as an indicator of SEP. It might capture all the aspects of SEP. And finally, we don't have enough data for offspring's BMI before 1 year old. And also the data points are not enough to look at details of the adiposity background, adiposity rebound. But there are also some strengths of the study. By using the unique 3-generation design, we could examine the SEP origin and look at the development of obesity across 3 generations. And we applied multi-level models to handle the repeated measurement of BMI and to look at the whole BMI growth patterns influenced by different factors. We also conducted several sensitivity analyses. So to sum up, the take-home message is we found children with parents who were overweight obese, they were set to a different BMI growth trajectories at an early stage of life. The difference persisted and got widened throughout childhood and adolescence. We also found grandparental lower socioeconomic position was related to higher offspring BMI trajectories, but there's not enough evidence to support grandparental SEP modify this intergenerational association of BMI. And finally, I would like to thank my supervision team. This is the last study of my PhD project, and huge help from my supervisors from both Bristol University and Aarhus University. Thank you so much.